Electrolytic cells. Objective: describe how electrolytic cells work. Describe the process of electrolysis in the decomposition of water and in the production of metals. Describe the process of electroplating. And finally, distinguish between voltaic and electrolytic cells. Electrolytic cells. Electrolytic cells use electrical energy to make a non-spontaneous redox reaction occur. Electrical energy is converted into chemical energy. This process is called electrolysis. The energy to drive this reaction is provided by an external power source, such as a battery. Electrolysis can be used to extract reactive metals from their ores, such as aluminum from bauxite. Electrolysis can also be used to decompose water into its elements, hydrogen and oxygen. Electrolytic cells can also be used to carry out electroplating, where a layer of a second metal is deposited on a metal surface to enhance its appearance and protect it from corrosion. Electroplating. Electroplating is the deposition of a thin layer of a metal on an object in an electrolytic cell. Here we have a spoon, which is going to be electroplated by silver. The spoon and silver is placed in a solution containing silver nitrate. The silver in the solution needs to gain an electron to become silver solid. Linking the spoon to a silver bar does not produce this reaction. It needs a battery. A battery is what drives the reaction. Electrons are pushed down towards the spoon, where the silver ions in the solution gains an electron to become silver solid. While on the other side, the silver bar loses an electron. The atoms in the silver bar loses an electron to become silver ions into the solution, replenishing the silver ions that is being deposited onto the spoon. Here, the silver solid loses an electron to become silver ion. The loss of electron is known as oxidation, while the gain of electron is known as reduction. Reduction occurs at a cathode, while oxidation occurs in the anode. The cathode is negatively charged because electrons are being pushed out into the solution there, while the silver bar is positive. An object may be electroplated to protect the base metal from corrosion or to make it more attractive. Electrolysis of water. The electrolysis of water breaks it down into its elements, hydrogen and oxygen. Pure water does not have enough ions in it and is not conductive enough for electrolysis. Therefore, an electrolyte such as sulfuric acid must be added. The hydrogen and sulfate ions plays no part in the electrode reactions. Here, 2 water molecules is broken up into oxygen gas plus 4 hydrogen ions plus 4 electrons. While on the other electrode, 4 water molecules gain 4 electrons, producing 2 hydrogen gas plus 4 hydroxide ions. The loss of electron is known as oxidation, while the gain of electron is known as reduction. Oxidation occurs at the anode, reduction occurs at the cathode. The anode is positive, the cathode is negative. By adding to 2 equations, we have 6 water molecules being broken down into 2 hydrogen molecule plus 1 oxygen molecule plus 4 hydrogen ions and 4 hydroxide ions. The 4 hydrogen ions react to the 4 hydroxide ions to make 4 water molecules. Subtracting the 4 water molecules from the initial 6 we started with, the final equation is 2 water molecule is broken down into 2 hydrogen molecule plus 1 oxygen molecule. This is the electrolysis of water. The hydrogen ions at the anode results in the anode being acidic, while the hydroxide ions at the cathode results in the cathode being basic. Voltaic cells versus electrolytic cells. In a voltaic cell, chemical energy is converted into electrical energy, while in electrolytic cells, electrical energy is converted into chemical energy. In a voltaic cell, the flow of electrons results from a spontaneous redox reaction, while in an electrolytic cell, the flow of electrons are caused by an outside power source, such as a battery, which causes a non-spontaneous redox reaction to occur. The anode is negative in a voltaic cell, while the cathode is positive, and it is made up of two half cells, while in an electrolytic cell, the anode is positive and the cathode is negative, and it is made up of one cell. The electrons flow from anode to cathode through the wire in both voltaic and electrolytic cells. Oxidation occurs at the anode for both cells, while reduction occurs at the cathode for both cells. Practice question 1. Write the half equation reactions at the anode and cathode for the electrolytic cells shown below. Here we have a zinc electrode being used to coat a metal. The zinc in solution, Zn2+, needs to gain 2 electrons to become Zn solid. The electrons are provided from the battery, where the Zn2+ in solution gains 2 electrons to become Zn solid around the metal ring. On the other side, the zinc electrode loses 2 electrons through the wire and become Zn2+ into the solution. The loss of electron is known as oxidation, while the gain of electron is known as reduction. Oxidation occurs at the anode, while reduction occurs at the cathode. The anode is positive and the cathode is negative. Practice question 2. The diagram and balance equation below represent the electrolysis of molten NaCl. When the switch is closed, which electrode will attract sodium ions? Examining the diagram further, we observe the electrons are going from left to right. The sodium in the solution, the sodium ions, will gain an electron to become sodium solid, while 2 chlorine ions in the solution will lose 2 electrons to become a chlorine molecule, gas. To balance the equation, if 2 electrons are lost, 2 electrons being gained, we have 2 sodium ions gaining 2 electrons to form 2 sodium atoms. Reduction is the gain of electron, while oxidation is the loss of electron. Reduction occurs at the cathode, while oxidation occurs at the anode. The cathode is negative, and the anode is positive. The sodium will move towards the negative electrode, or the cathode, while the chlorine will move towards a positive electrode, or the anode. Therefore, question 1, when the switch is closed, the electrode that will attract the sodium ions is the cathode, or the negative electrode. The purpose of the battery in the electrolytic cell, it forces a non-spontaneous reaction to occur. The half equation reaction that occurs in this cell, the reduction part, is sodium ion gaining an electron to form a sodium solid, or 2 sodium ions gaining 2 electrons to form 2 sodium solid.